Hello guys and welcome. I hope that you're having a good day or good morning or good evening. My name is I play 4K, aka I play 8K, aka I play 16K, or UHDking. During this video today, I'm going to show you Counter-Strike Global Offensive running in 16K resolution, rendered in real time, which is 133 megapixels, rendered in real time on a single Titan RTX video card that is going to be stuck and overclocked, and the old school Xeon E5-2697v2 CPU. So as you can guess, I'm using this system as my workstation, as the 8K resolution video encoder and 3ds Max renderer. So whatever I'm rendering the composition, 3D scenes into the images or video file, I'm using this system a lot to be able to utilize the 24 threads, because this Xeon E5-2697v2 CPU, enterprise CPU from 2013, that was priced in 2013 $2,500, comes with 12 physical cores, and with the hyper threading technology, additional 12 virtual cores, which is 24 virtual cores under the Windows or Linux. So we can utilize a lot of computing potential power on this CPU. And this is exactly my workstation. This is not my gaming rig, but I decided to show you how the workstation with the strategic, great top of the line video card can perform in PC games. And today I decided to go ahead and show you Counter-Strike Go running in 16K resolution. This is not the first Counter-Strike Go or Counter-Strike CSGO, Counter-Strike Global Offensive gameplay in 16K resolution. I was the first YouTuber that recorded 16K resolution back in 2018, guys, with the two RTX 2080 Ti video cards and single RTX 2080 Ti video card on my gaming PC, which is the Core i9 9900K, overclock at 5.3 gigahertz. Okay, but this is just a video on the workstation. Keep in mind that I also going to show you the Counter-Strike Go or CSGO in 16K resolution gameplay, similar benchmark on my gaming rig, which is the i9 9900K, overclock at 5.3 gigahertz. So we can use this Titan RTX and two Titan RTXs in SLI, and we can compare the data with single RTX 2080 Ti and two RTX 2080 Ti video cards in SLI. Okay, so enough talking. But this is a little introduction. In the end of this video, I'm going to show you the CPU Z, GPU Z, and IDA 64 benchmarks. It's going to be a nice details for those who's looking to get some facts and some hardware specs. So this is how we're going to do it, guys. So it's going to be maxed out 16K resolution, which is 15,360 pixels on width and 8,640 pixels on height. I'm running, guys, full screen windowed mode, not the full screen. Full screen sometimes is flickering, I'm not sure why. So my desktop is also running 16K resolution. This is very important, to set your desktop to 16K resolution and 100% scale in your desktop, because you're running full screen window mode for the proper VRAM utilization and the FPS at the left top corner. As you can see, left top corner, self-explanatory. So this is how we're going to rock. Everything will be maxed out except the multi-sampling anti-aliasing mode is none. Everything else is maxed out. And I'm going to play a demo file that I'm always playing since RTX 2080 Ti benchmarking. So this is how we're going to bench it. Keep in mind, guys, a lot of grand finals in 16K resolution will be uploaded to the UHDking.com YouTube channel. You don't want to miss it. To watch all the finals of the CSGO in 16K resolution over my channel. I'm going to dedicate the time to you guys, to CSGO lovers. So don't forget to smash that like button. So we're gonna play the grand final match 103, where the CS Gaming versus the Team Liquid. And I'm going to bench right now Titan RTX completely stock, control with the drivers. Then I'm going to overclock it through the software, and then I'm going to go to lowest possible settings at 16K resolution, because some of my subscribers was asking for that, and I'm going to dedicate to them. So don't forget to smash that like button. So how I removed that, it was on the screen, it was a bunch of noise. how, like stats and stuff like that, how I remove that. So I called the console, and in the console I type the cl underscore draw hood space 0. 0 hides all the stats, 1 brings the stats. Hopefully guys this makes sense. So this is completely Titan RTX is running stock, and as again it's using dual fan Nvidia cooling solution and also Nvidia thermal compound paste. I did not use any liquid metal thermal compound paste over here. This is completely stock video card and running completely stock. We're about to overclock it. You want to keep your eye at the left top corner. As again guys, I'm coming in real time. English is not my first language, but I'm being PC gamer since 1997, PC overclocker, PC enthusiast since 1998, and graphics designer since 2001, web developer since 2000, software developer since 2007, and 3D artist since 2003. So I have a lot of information to share with you guys. And game developer since, I would say, 2009, but didn't develop yet any final product. I'm about to do so in 2021. It's going to be the iOS games and couple iOS apps as well. So guys, as we can see, not bad. And keep in mind that Construct Global Offensive supporting the SLI, so we can run 2 Titan RTXs in SLI, and I'm going to show you 2 Titan RTXs in SLI in this game, and probably on this desktop workstation as well. So you will have a better ability to compute and find out exactly how much performance we gain when I'm running single Titan RTX versus the 2 Titan RTXs in SLI. And I'm going to use the same workstation. Then the gaming week as well, I'm going to show you single and dual, which is Titan RTXs. And there is a possibility I'm going to show you 2 Titan RTXs in my workstation 2021 with the 2 2699v3 CPUs. But as again, for those type of CPUs, you don't want to have the top of the line video card unless you're going to use it throughout your workstation tasks. And guys, FFmpeg++ application that I'm developing will be able to utilize your CPU and GPU while it's doing the video encoding at the same time, which is amazing. So you can run 2 parallel tasks, one on CPU, one on GPU, and compute 2 different videos, encoding 2 different 8K resolution videos. And of course GPU going to be faster, but I'm going to include guys CPU and GPU benchmarks in FFmpeg++ freeware application that I'm developing, so we can bench and find out which system will be as fastest workstation in the world. It's going to be amazing. It's going to be like 3D Mark. So it's going to be developed by me. So FFmpeg++ not only going to encode your videos, and the ability is going to be amazing. It's going to feature the UHDking profile in 8K resolution for YouTube. So pretty much it's taking 150 gigabytes of the Shadowplay 8K resolution video and compressing it in 8K resolution video, which will be like 60 gigabytes. The quality will be almost the same, and I'm going to include this type of profiles for you if in my FFmpeg++ application that I'm currently developing. It's going to be amazing, guys. So this is why I'm going to test this workstation with the 72 cores on the dual socket to find out how much gain we can gain on that workstation while we're doing the video encoding. I'm pretty sure 3ds Max Studio will show us the gain, but how much the FFmpeg gain will be, and I think it's going to be at least 2 times, guys, but we're going to find out. And this is exactly why you're going to guys need to use this type of systems. You're going to be strategic, or you can use the system all in one, because Xeon's E5 version 2 and a special version 3 will be very cheap in 2021. The reason why I like the version 3, because version 3 have a better capabilities to be overclockable, even if Xeon E5 2600 series V2 and V3 is kinda enterprise server CPUs are not overclockable, but there is ways how to overclock them. But version 3 has a better ways to go to higher frequencies, and core per core, frequency per frequency, version 3 is much cheaper, used like new on eBay than version 2, keep that in mind. So that's why I think if you're building all-in-one system, you probably want to look at the V3, because V3 is going to be a great system because you can overclock it. It's going to be a great all-in-one system, like gaming. It's going to be like video rendering, 3D rendering, Photoshop, whatever you're doing. But pretty much gaming and Photoshop, guys, requires the higher frequencies versus the core count. But video encoding and 3D rendering requires a lot of cores. So this is pretty much when you're building the computer, this is the important information for you to go for. Because if you're not going to follow those rules, this is the best rules for you to follow, then you're going to complain, like something doesn't work right and stuff like that. To avoid that, just go ahead and watch my YouTube channel. I'm explaining pretty much from multi-angle type of information for any kind of intellectual capable personality. So a lot of great information, guys, is available for you to think about it. So you're going to build a better PCs, plus you will have a better abilities to utilize them to benefit as best as you can. To build a PC is a great motivation for you for the next steps, and you wanna already have in your head why you need to build this PC. So let's say the game developing, the video encoding developing, like I'm doing, is great for me. So you're already at least making the excuses towards a positive vector towards your goal. So it's better, it's much better just when you're going to build a PC without any goals. You want to have a goals, guys, while you're doing that. Also a great idea why you want to be in this hobby, because you don't want to just be in this hobby, you want to have it like 2-in-1 while doing some other goals based with the technology, such as software development, video editing, graphic design, web development, or something like that. So you can utilize this PC builds in your projects as well and gain 2-in-1 values, guys. All my YouTube channels is all about the values, 2-in-1, 3-in-1. So keep watching. Don't forget to smash that like button. So we saw it, guys, right? So this is how it was stock. Right now what I'm gonna do, the Titan RTX was controlled by the driver and it wasn't running so fast. I'm just real quick going to bring the MS Afterburner. Look how it is. MS Afterburner is such a small, because as again my desktop is running 100% 16K resolution, 15,360 pixels by 8,640 pixels. So this is how I'm going to do. I'm going to overclock the VRAM plus 1000 megahertz additional, which will be 2000 megahertz instead of 14,000 megahertz. We're going to jump to 16,000 megahertz, and GPU will be overclocked by 100 megahertz. We're going to apply that, and we're going to jump into the game. FPS will increase. Usually this software overclock gain 7-10% of the FPS boost through the overclock. This is the formula, and it always was working throughout the different years, throughout the different technologies. Software overclocking, guys, gives you additional 10%, and you want to take that 10%. It's just gonna gives you 10%. Why not, right? It's for free. I consider this safe. And right now, as you can see, my VRAM utilization, my VRAM frequency is 16,000 megahertz instead of 14,000 megahertz, and my GPU went a little bit higher frequency as well, so we're going to receive a higher FPS.
Well, we're about to find out. I mean, if Hiko can actually win a tournament, he said it himself not too long ago. If I don't win,
and after this, I'm just going to go ahead and lower the setting, guys, for you, and it's going to be the last benchmark during this video, and I'm going to show you a little bit of my system, CPU Z, IDA 64, all the hardware specifications. And we're going to go ahead and wrap it up, and hopefully I'm going to insert 2 Titan RTXs. And imagine right now, guys, these 2 cores utilizing 30 megabytes of level third CPU cache. 30 megabytes per 2 CPU cores means each CPU core is right now utilizing 50 megabytes of level third cache. This CPU is going to boost up, especially in the game engines such as the Source game engine or X-Ray game engine in Stalker game series, or maybe software such as Quake 3, Quake 2, Quake 1, and Quake 4. They're going to love this high level third cache and CPU. And of course, the most important thing what they're going to love the frequency, and the frequency right now is 3600 megahertz per each core. So Usually guys, this CPU is starting with the 2700 megahertz with the AVX instructions when 12 cores using 24 threads, but when it's just regular instructions, it's using the 3000 megahertz or 3 gigahertz per core when it's running stock. With my overclock 12 core 24 threads is running 3.2 gigahertz, additional 200 megahertz. No matter what kind of scenarios, you're going to be higher by 200 megahertz per any scenarios when running stock with my cheating overclocking on this enterprise CPU. 200 megahertz, right? So then it's 3.2 100 megahertz in the games when you're running 12 core 24 threads. So then I used some intellect and I decided to increase the CPU frequency by lowering my CPU cores. The lower cores, the CPU automatically unlocks the higher multiplier. This is how it's designed, and it's controlled as again automatically, because this is enterprise CPU. You have no control over your multipliers. So 2 cores with my overclock going to run 3600 megahertz per each core in the CPU, and it's great when you're not going to pretty much go above 90%, and you're not going to see above 90% in PC games. Utilization is going to be a great. Means that you don't need additional extra at least 1 thread. It's better to be a physical core for the maximum possible FPS, and we never saw above 90% at all during my gameplay right now during this test. So we're Gucci in terms of our CPU core utilization. Okay, we don't need any more additional CPU cores or any more additional CPU threads. Hopefully guys this makes sense. But we boost up our frequency from 3.2 to 3600, additional 400 megahertz, and in PC games it loves guys the frequency versus the cores. Remember that if your core utilization below 80% in the games, you never saw above 80%, you're Gucci. The most important thing right now, you gotta be focused on frequency on your CPU core, and this is exactly what we did. We boosted up to 3600 megahertz. We're Gucci on our CPU cores in this particular game though at 16K resolution. The lower resolution, the more CPU cores it's needed somehow, and the lower GPU utilization will receive with the lower resolution. So that's why you need that a lot of CPU cores that AMD is promoting right now, only guys for the low resolutions. This is why those multi-million subscribers marketers YouTube channel, they saying, oh look at this, AMD CPU is so great, and during the benchmarks they showing you 1080p and 1440p benchmarking on top end of the CPUs. Why are they doing that? Because 4K resolution and above going to utilize less of your CPU cores and is going to bring the most stress on your GPU, and this is exactly how you want to do it, because GPU is much more faster computer part than CPU, at least by 5 times, but it goes usually by 7-10 times. GPU will be faster than the CPU, so you want to first the GPU compute some operations and tasks before the CPU comes, and this is forcible under the Windows as I saw Windows 7 and Windows 8, Windows 10 operating systems, when you're running the resolution above 4K resolution, especially when the resolution starts above 8K resolution, the Windows operating system kernel is forcing to use the GPU first and then the CPU, because Microsoft understands the GPU on your computer is the fastest possible component, and it's better to give the task through that under that heavy resolution and then through the CPU. They just realizing, okay, he's using very high resolution, most likely he's having a great GPU, otherwise what's the point for him as a user, and we're going to go ahead and do the task first from the GPU and then into the CPU, and this is exactly what it is. And when you're running 16K resolution, the most stress of everything is going on through the GPU, and just a little bit of test going through the CPU. That's why the higher frequency is better. When there's a little test sometimes going through the CPU, at the higher frequency they're going to reach that, it will be the better. Hopefully guys makes sense. I just explained to you real quick a lot of information. Go ahead and replay that and listen to it again a couple times, and then you will realize it was just a 15 years of experience in just a little short 3.5 rep music. Hopefully guys you enjoy that. Anyways, hopefully guys you celebrated a great happy new 2021 year, and hopefully we're going to get rid of these viruses and pretty much gonna get back as we were before. Look at this, it's just amazing. As you can see, right now we are above 30 FPS at least. And again, this game supports the SLI. That means that I can put 2 Titan RTX as an SLI and at least 1.9 times make my FPS boost. And guys, as again, I will try to show you on this particular workstation with 2 Titan RTX and SLI. I think a lot of people want to see how 2 cores and CPU with 15 megabyte level 3rd cache and the CPU cores can do with 2 Titan RTXs and 3600 megahertz. Guys, let me tell you, on this Xeon CPU, 2 cores, 3 cores, and 4 cores are amazing. They scaling so they scale like unbelievable well. Like they scaling like nothing that I saw. They scaling just when you scaling on this CPU 1 core, 2 core, 3 core, 4 core. They scaling better than those 1, 2, 3, 4 cores on the Core i9 9900K. They're just scaling so well. It's unbelievable. They just showing scale on 2 core 2 threads. Scaling is 2 times, completely 2 times. So it means the excellent CPU scaling. And I think that level 3rd cache, shared cache, which is 30 megabytes just for 2 core 2 threads, only 15 megabytes per each CPU cores, doing a lot of things. And this is what it is. So what we're gonna do right now, I'm just going to go ahead and reboot it and to the lowest possible settings. So guys, that's it. So also the point of my video is to show you the future, and the point of my video is to show you as a proof, as a fact. But a lot of naysayers even right now still couldn't analyze the data that they're going to watch, to show you guys that in the PC gaming the most important thing should be your video card. You can build up your PC with the old part like a CPU, but be very strategic why you want to use that CPU. If it's going to be for the gaming, probably use the Xeon 1680 and overclock it, pick it up cheaply, but only when you're going to pick it up for the price $120 and below. For price $180, better go ahead and pick it up yourself i5 8600K, because that CPU can go 5 gigahertz and it's going to destroy 1680 Xeon V2 at anything. Keep that in mind. Okay, so a lot of information provided to you. Right now what we're gonna do, right now we're going to go to the lowest possible settings, and it's going to be the last test. So the lowest possible settings, so I'm going to go ahead and shadows, we could probably also run the shadows at low. Let's go put shadows at low. Pretty much when you're running 16K resolution or anything above 8K resolution, those shadows, guys, all the time can go to low, because pretty much low and very high in terms of the shadows will be the difference only how soft the shadows is. So low to high, keep that in mind. Model texture details we want to keep at high, because what's the point to run 16K resolution when everything will be not at 16K resolution in terms of the texture quality. Texture streaming, let's go ahead and disable that. Effect details I want to keep at low, so details such as the smoke, like lower particles and stuff. Shadows I want to keep at low, so pretty much low as possible. This goes for my subscribers, so don't forget to smash that like button. A lot of people that was asking. Boost player contrast, let's disable that. Multicolor rendering enable, of course. Disable textual filtering. Let's go bilinear. Let's just go at completely low. But as again, right now we're going to stress a lot of CPU. There is a possibility that I'm going to overload my CPU. So when you're going to see CPU gonna go to 100%, especially when we're going to be in the game menu, when you're going to load some files, it's going to go to 100%. What I find out when it's loading a lot of files, guys, under Windows 10, 2 core 2 threads is not enough. You want to have 4 core 4 thread CPU just to transfer some files without pretty much lowering the speed during that task. And Uber shaders we're gonna disable. So right now pretty much we disabling visuals, so we're going to create a higher stress on our CPU, because when the very lowest possible scenario, visuals gonna stress our CPU more than GPU. Keep that in mind. I'm going to go ahead and apply that. As again, guys, it's recording in real time today with Nvidia Shadow Player that was hacked, and it's recording in 8K resolution. It was hacked to the system RAM debugging tool in runtime. Width and height of the video container was changed. So don't forget to smash that like button and watch this video in your YouTube video player, switch it to 4320p or 8K resolution for the maximum best possible visual experience. This is how we're gonna do it. Lowest possible preset. So right now what I'm gonna do, look how small my mouse cursor. I'm going to go ahead and play the same demo, and with the lowest possible preset, you're gonna see my CPU utilization went to 100% immediately during the loading time. As already I explained to you, it happening because it's loading some files, and under Windows 10 the speed of the device is so fast, 2 core 2 threads is not enough, guys, to process all this data. But during the gameplay you will see it's going to go automatically. After it's going to load all the files, it's going to go automatically to below 80%, and we want to keep it below 80%, as again we don't want to keep during the gameplay 90% and above. This is a clear signal that we need to add at least 1 thread, and better to be a physical core, at least 1 physical core, but the best scenario will be to add 2 physical cores. But every time I'm adding more cores to my CPU, my automatic turbo boost multiplier goes to lower value, and as again I do not have control over my multiplier like on the desktop CPUs that is overclockable. This is the server enterprise CPU, and do not, guys, be in illusions that some of motherboard will unlock it for you. On this V2 CPU, 2697v2, this particular CPU, there's nothing what you can do. You cannot overclock it through the multiplier. You can only tweak it like this. So you assume the automatic turbo boost using the higher multiplier, starting with 5 cores, then 4 cores higher multiplier, 3 cores higher multiplier, 2 cores higher multiplier, and maximum higher multiplier, which is the 35th multiplier for the Xeon E5-2697v2 is used with 1 core, 35 multipliers. So what I did, just because on this gaming overclocking motherboard I can overclock it to the BCLK clock, which is additionally it's running 100 MHz by stock times the multiplier, which is 100 MHz times the multiplier is going to be 3.5 GHz just for 1 core, 1 thread when running on this CPU by the manufacturer, right? So what I did, instead of 100 MHz, I increased the multiplier frequency on this BCLK 100 MHz to 106 MHz, so 6 additional megahertz times 35, it boosts me up additional 200 MHz, 180 MHz to be specific. So 200 MHz boost, no matter what kind of scenario, no matter what kind of automatic boost CPU deciding to boost up my CPU, are already going to be 200 MHz higher. So this is a little cheat for the CPU, guys, especially when you're playing PC games, as again the higher frequency the better. So you're going to bring your CPU to the maximum possible frequency. Then I look at my stats and I find out that I can run 2 core 2 thread CPU maxed out and enjoy it, and this is at 16K resolution. As again, the lower resolution such as 8K resolution will require 4 core 4 threads. 2 cores will be overloaded in the game. It's going to be 100% constantly. That means that you're bottlenecking the game through the CPU core, and you need to add additional 1 core, but the best 2 cores. So in our scenario, 2 cores will use 32 multiplier, 3 cores 33 multiplier, 2 cores 34 multiplier, and 1 core 35 multiplier. Okay, so lower multiplier the more cores. So I decided 2 cores 2 threads is more than enough. Right now, as you can see, we never reach even to 80% during the gameplay, and that means that we don't need additional cores. We're good to go, as again each physical CPU cores, guys, can produce so many virtual threads. You have no idea. It's not like only 2 threads for each physical core with the hyper-threading technology. No, a lot of virtual cores. Each CPU cores can produce like 1,000, 2,000 physical virtual, not physical, but virtual cores in Windows, and this is exactly what it is. And it doesn't matter, guys, if it's splitting between the cores or it's producing those less amount of the cores. The speed will be the same if you're doing something like PC gaming, when that instruction happening real quick once or twice. It's not happening all the time. So that means that you need to have the higher frequency. This is exactly what it is. The higher frequency in PC games, the newer generation of the CPU versus the current generation of the CPU. By one newer generation of the CPU will be 3% faster frequency, megahertz per megahertz. Keep that in mind. So this is the 4 Gen Intel CPU cores kind of technology right here going on the Xeon E5-2697v2 CPU. So pretty much same as 4000 series Core i7 CPUs, guys, on this X79 motherboard. And I was running before in 2013, 2014 on this motherboard. I was running on this Gigabyte X79 E3 version 1.1. I was running the Core i7 4930K that was overclocked from 3.4 gigahertz to 4.2 gigahertz, guys. And believe me or not, those 4.2 gigahertz right now during this test will overperform the Xeon because they're faster by 400 megahertz per each core. And it was stable with all those cores. I would probably, 2 cores would probably push it to 4.6 gigahertz, but higher frequency is better results, keep that in mind. But this again, this is a workstation, this is not a gaming PC, but the reason of this test to show you what if for the low budget folks you're going to decide to use it like all-in-one system, plus you're doing some 3D rendering, you like that, you like the video encoding, you're doing some YouTube. Is this system going to be good enough? And I want to let you know, guys, it is. I got the CPU back in February, end of the February, and I was using this system without touching my gaming i9-9900K. By the way, the i9-9900K is 10% faster in video encoding with only 8 cores, 16 threads, guys. Completely stock CPU than this CPU with 24 threads. That CPU is 10% faster through video encoding. So that means that CPU is faster. Even it doesn't matter how many cores I use. But this CPU I purchased for $129. I sold my i7 4930K for $100. So pretty much I purchased this CPU for $29. Installing this gaming motherboard, guys. Of course, you need to have F20 bias on this X79 Ultra Durable 3 version 1.1. This is not version 1.0. This is version 1.1, guys. It was 2 different versions of this motherboard. With F20 bias, the CPU is bootable. Otherwise, the CPU is not going to be boot on any other biases. So I flashed the bias with my i7 4930K and installed the CPU, guys. And for $29, I increased by additional 12 threads, and it's big difference, guys, when we're talking video encoding. 4930K overclocked at 4.2 gigahertz versus this CPU just running 3.2 gigahertz while doing video encoding, but running 24 threads. This CPU is going to be outperformed at 4930K throughout the video encoding, including the 3D rendering, and I'm doing those a lot. So as again, this is my workstation, my secondary system. This is a great system for the video encoding, keep that in mind, especially if you're having the laying around X79 motherboard. Otherwise, guys, you want to get yourself X99 motherboard if you're building completely from scratch. Version 3 E5 Xeon E5 2600 series version 3 is the better, because the price core per core and going to be cheaper in version 3 than version 2, and version 3 is overclockable. You can tweak it to higher frequencies, and completely it's going to be the next generation, frequency per frequency 3% as minimum faster, version 3 version 2. Hopefully, guys, this makes sense. Let me quit the construct. So guys, this is my desktop. As you can see in the middle, this is the system that I'm running today. Water cooled by the Corsair H100i RGB XT. I believe 3rd generation of the H100i water coolers by Corsair. Beautiful cooler, but overpriced. You can get for $79 similar performance, or for $89 you can get the NR Max 3600 millimeter radiator versus this one 240 millimeter radiator. That one going to cool you better. Over here at the right top corner, this is my gaming rack, which is dual Titan RTXs, i9-9900K overclocked at 5.3 gigahertz. The fastest gaming rig in 2019. In the beginning of 2020, in the February of 2020, this system was the top 14 systems world record in the 3D Mark Firestrike Ultra, and I know for sure 10 people was running LN2 on top of me, so I was number 14, and I was faster than Canadian Canucks, those guys, faster than Nexus Gamers, faster than that 50 Cent Jay-Z. I have the video, guys, where you can go ahead and look it up, that video, over the UHDking.com YouTube channel. But let me show you, to prove you guys, this is very important, that your desktop should be at 16K resolution set at 100% scale. Let me open up. I open up the wrong deal. 1 second. This is very important when you're doing that. Here we go. Let me use the magnifier tool like that. Okay, your desktop should be like that. So real quick about my hardware, and we're going to go ahead and wrap it up. Hopefully guys you enjoyed this video, because I definitely did. Cannot wait to run this on my gaming rig, which is i9-9900K. It's going to be boosted up to 5.3 gigahertz, very fast, and the latency delay on my DDR4 5000 megahertz CL18, that is overclock on that system, to DDR4 3000 megahertz. But look at this, check it out, CAS CL10. Okay, this is unheard of for DDR4. It's just so fast. Cannot wait to do the CSGO with 2 Titan RTXs on that system. It's going to be nice. But anyways guys, over here, what are we looking over here? We're looking over here at the IDA64 GPU benchmark when it's using the OpenCL API, when we can compare the CPU versus the GPU. Pretty much it's a rendering process, and we can see how faster the GPU versus the CPU. But the CPU is only running 2 core 2 threads, keep that in mind. And this is the IDA64 cache and memory benchmark for this CPU. Somehow when I'm running 2 core 2 threads, my read, write and copy very low guys. It's below 26,000 megabytes, as you can see. When I'm running the 12 core 24 threads over here, or 4 core 4 threads, it's going to go like 30 megabytes per second read, write and copy. Okay, latency can go to 92 when you're running CL7, but it's not going to be stable after 30-40 minutes. It's blue screen. This is completely 24/7 rock solid stable, keep that in mind. And even if this DDR4 is 1866 megahertz crucial ballistics CL9, it's not stable on this particular CPU. It was stable on the i7-4930K and that gaming CPU. It was also stable when I tested on 2630 version 1 CPU, which was amazing CPU, but was only 6 core 6 threads. Very low frequency but very fast Xeon guys. Version 1.0, but as again, you don't want to run any version 1.0. If you want to run on this motherboard, you want to run for the gaming Xeon 1680 version 2, or if you're running a workstation, this is going to be your top for this motherboard, keep that in mind. And you can pick up the CPU in the end of 2021 for $89. This is amazing. But this CPU is going to be amazing if you're going to get a great price, and if you're going to get the dual socket Chinese motherboard, the total system, you can, if you're going to get for $89 the CPU, 2 of them, and just Chinese motherboard, the total system will cost you $300 plus the add $400 total, about 64 gigabyte DDR3. You will be Gucci guys as workstation with the total 48 threads or 48 virtual cores. But check out my video 2 Xeon 2697v2 and X79 chipset. That's going to be even faster than this one on amount of cores, frequencies and everything. It's going to be a great video guys. Alright, so this is how it was running stock guys. Alright, check it out. My pixel fill rate 179 gigapixels, my textual fill rate 538 gigapixels, my bandwidth 768 gigabytes per second, almost as GDDR6X on the RTX 3000 series, on RTX 3080, almost as fast, I would say by 60 gigabytes per second slower. But when I'm going to bring this down guys, you're gonna see the overclock down, those abilities will disappear. Check it out, this extra overclock will go so low. Here we go, I just bring it down. As you can see, we just lose a lot of guys performance that we achieve for free, and I very recommend to overclock to the software. It's safe, but as again, everything what you see during this video, you're doing on your own risks and expenses, keep that in mind. So let me real quick guys open up the CPU Z, show you in my CPU Z what's going on. We're gonna move forward. Okay, let me open up the CPU Z. So my Gigabyte X79 gave me the ability to unlock the disable and enable some cores, hyper-threading technology, which is amazing, and you can manipulate by these values guys by manipulating those values, you can achieve the higher frequencies, and those higher frequencies will play a big role. The lower CPU cores but higher frequencies when you're doing the PC games. So I show you guys how intellectually pretty much unlock some abilities for the higher FPS in PC games when you're running the Xeon's enterprise CPUs. Hopefully guys this makes sense, you learn a lot. So this is the CPU Z. Again, I took the wallpaper picture with my iPhone XR, guys. Not a great quality, I know, but as you can see, the desktop set at 16K resolution, 3600 MHz, 3.6 GHz per each core, 2 core, 2 threads, 30 MB level toward cache shared, so 15 MB per each core. So it's doing great job, guys, especially in old school games. And just because a lot of old school games that I'm testing in 60K resolution, this CPU will scream fast. Unfortunately, I'm going to retire this CPU. It was a great CPU. I didn't touch my gaming PC since I built the system in March 2020 all the way till January 2021, and right now I'm going to retire this and I'm going to build myself a new dual socket at 2699v3, guys. That CPU going to be amazing. This is the motherboard. As again, F20 BIOS required, can be downloaded from the Gigabyte motherboard, running 16X on PCI Express. You can install 4 video cards here, running 8 times, but 4 video cards, no problem, for sure, 8 times. And SLI, quad SLI, which you don't need anything faster than that. This is PCI Express version 3.0 slots. So it's running, guys, 565 megahertz because DDR3 times 2, 1130 megahertz, 1130 megahertz. CL9 1T command, stable, quad channel, 256-bit. Which is, by the way, as fast as DDR4, 2133 megahertz CL18. As fast. Can you believe it? So the quad channel is kind of fast. That technology, server technology, is not bad. It's not 2 times versus the dual channel, but it's 1.5 times boost out of nothing. So 4 sticks, 8 gigabytes. Okay. This is the Titan RTX. As you can see, it went back to 7000 megahertz per hour GDDR6, so 14,000 megahertz because GDDR6. But we were running 16,000 megahertz. Samsung GDDR6, same memory as on RTX 2080 Ti video card, but RTX 2080 Ti video card only having 11 gigabytes of VRAM, and this one has 24 gigabytes of VRAM that allow us today to run the 16K resolution. That's pretty much it, guys. Alright, I increased the voltage just in case, so we're not gonna crash. 3.6 gigahertz per each core, not bad. And we didn't bottlenecking in terms of our CPU cores. Hopefully guys you enjoyed this video. Right now I'm putting some great videos for you to check out. Go ahead and check out my gaming rig, 2 RTX 2080 Ti and SLI in Counter-Strike Go or CSGO 16K resolution, single RTX 2080 Ti in CSGO 16K resolution. But you saw we are overloading like 14,000 megabytes of our VRAM usage, so pretty much when RTX 2080 Ti is running that game, it's offloading some data from the VRAM into the system RAM. And as we learned, the Nvidia driver can unload all the way to 5 gigabytes of data from the VRAM into the system RAM before it's going to crash the game, and it's still managing a great FPS. But hopefully you learned a lot during this video. As again, don't forget to smash that like button and subscribe for more great videos. I play 4K, AK, I play 8K, AK, I play 16K, AK, UHDking. What we do today. Thank you so much for watching. Till the next time. Stay safe. Have a great day.